Hello again, dear lovely students. I hope everyone is well and safe anywhere and everywhere. We are continuing crystallizing the paper M1 October 2024. Let's crystallize question 5. Question 5 is obviously about pulley, but we read the question carefully, label information, write the sufficient steps like we'll be doing now in the next few minutes. Two particles, P and Q, have masses 3 kilograms and 5 kilograms. Respectively, the particles are connected by a light inextensible string which passes over a smooth pulley. This is the pulley here. The particles are released from rest with the string and taut and have the hanging parts of the string vertical as shown in the figure, means the pulley carrying vertical to the horizontal both of particles. Immediately after the particles are released from rest, particle P moves upwards. Of course, he doesn't need to say that the particle moves upwards with the acceleration A, because it's clear that this 5 is more than 3, dear students, so this is the heavier. So this is the main direction of motion. So this will go first, it's the main force, and this will go up, of course. So before we continue reading, we know that the string has a force of tension in this direction, and the weight of 3 is 3g. But he started with this that he wants here. Write down the equation of motion for P. P, which is the 3 kilograms, simply in seconds, T minus 3A, 3G, sorry, is equal to 3A. He wants to start, so follow him. For part B, he wants the value of T, as usually we do in the questions, exams we don't do so like part of the question. We usually, as always, tell my students anywhere, this is the main force, this is the tension towards the pulley, we resolve, then we label, dear students. We start better with the particles resolving the forces on the heavier particle in this question. So 5G is the main force. This is that we have to start every time for particle, but he wants in particle A, in part A, to resolve for P, which is the 3. It's better to do this in these questions. Then by adding the two equations together, you will get 2G negative T with T gone equals 8A. Find the acceleration of the system first, which is D over 4, which is in decimal 2.45 meter per second squared. Then we go to any equation we want, since T here with positive, by equation 2, make T the subject, equals 3A plus 3G, which is 3 times G over 4 plus 3G. So this implies that T is equal to 15 over 4G in decimal 36.75 newtons, getting the full marks, which is 4. As usually say, I'm fast. If you are not familiar with this topic, say write in the comments. I'll be responding to your comments, and I'll be solving other papers. Already I will be doing other papers. But if the many students or majority of my students following, they have a problem with the topic, just communicate, dear engineers and doctors. For part C, the total force acting on the pulley due to the string of magnitude F newtons. So he wants the force of the pulley in simple words, or exerted on the pulley, which has a formula, dear students. Part C, force exerted in the pulley is always 2t cosine an angle alpha over 2, where alpha is the angle, it's nice formula guys, between the two parts of the string. Which is on the pulley, which is in this question 0. This is the pulley, let's make it small. This is the direction, this is here the direction. Alpha in this question is 0. So simply in this question, force of the pulley, which he named it by F, 2t cosine 0, which is 1. If you don't memorize that cosine 0 is 1, use the calculator. Just substitute t in this formula. You will get 73.5 newtons. We have alternative ways, of course, but this is the easiest way, and it works with any question with the pulleys. It's the advantage for this formula. Part C is done. For part D, of course, usually in these questions in M1, usually they ask a part like you have to think in this part. Initially, Q, which is if the 5 kilograms is 10 meters above the horizontal ground, and P is more than 2 meters below the pulley. I will be showing this information on the last page, not on this. I'm just reading the question. At the instant when Q has descended distance 2 meters, the string breaks. We have to pay attention to these keywords. And the Q falls to the ground. Find the speed of Q at the instant it hits the ground. Let's illustrate part D here. Q already, which is the 5 kilograms, is 10 meters above the ground. As the question said. And this is 2 meters below the pulley. The idea in this question, dear lovely students, when this goes down, it's 2 parts of motion. This will go 2 meters due to the acceleration of the system. So we may calculate the V, the speed. I will show the speed or after falling or descending 2 meters. What do you have? It was released from rest. U is 0. The acceleration of the system G over 5, which is 2.45 as we calculated in part A, and H is 2 meters. So we find first the speed when it descends or it falls 2 meters. Of course, using the formula V squared equals U squared plus 2AH. Just by substituting the formulas, V squared equals U squared, which is 0 in this part, plus 2 times 2, 4, 5 times 2. By using the calculator, simplifying, this is 9.8. By writing the positive square root, which is 3 and 13 meter per second. The second part in different color, dear students. Now, I will do it here to sketch it to you. This is particle Q now in here. 8 meters left. But the string breaks. So now the acceleration of the system is the gravity, which is A equals 9.8. And what will happen to this, dear lovely engineers and doctors? V here, it's instantly U here. So U now is 3.13. H equals 8 meters. He wants V when it hits the ground. So V that we want here, we use again the same formula since AUVH, which is V squared equals U squared plus 2GH in this, since it's going due gravity down, so G is positive. So V squared equals 3.13 squared plus 2 times 9.8 times 8 meters. By the calculator, guys, it's almost 166.6. By adding the positive square root, getting 12.9 meter per second. To remind you again, have problem with any topic like these special skills, how you read the question, how you read the sufficient steps, stay updated to my channel, communicate in the comments. I'll be helping you as usually, praying for you that everyone is safe and well.